In this example, we're going to use the graph to find the right, left, and two-sided limits. Use the graph to find the indicated limits, and in step 1, we're going to find the limit as x approaches -3 from the left of f of x. We'll first start off by highlighting x equal to -3 on the x-axis. So I found -3, 1, 2, 3 on, how about this other -3? Shut up. Don't you talk about me. Don't you judge me. Negative. I'm tired. So we isolate -3 on the x-axis. And then we notice that we're approaching -3 from the left. So I want to go to the left of -3. So I'll highlight that as well. So when I'm going from the left, I'll notice that I'm on the branch of the graph that sits above the x-axis, and it's line ray, not a line ray, a ray with an open circle at -3, 4. So as I'm approaching -3 from the left, I'm going to be on the purple graph that's drawn above the x-axis. So I'm going down, and I can see that my y values are getting closer and closer to the y value of 4. So therefore my limit is going to equal 4. For step 2, we're going to find the limit as x approaches -3, but this time from the right, not the left, of f of x. So again, we'll isolate -3. Let's hope I do better this time. Yeah, that was funny. And then we're going to come in from the right. So if we're coming in from the right, that's to the right of -3. Then I notice that when I'm on the right-hand side, I'm on this kind of squiggly guy that goes underneath the x-axis on one part and then slides up above. And it has an open circle at both of the ends of the squiggle. So since I'm concerned about -3, I want to label that ordered pair when x is -3. So even though it's an open circle, that means I don't include it. That's -3. And the y value looks like that's -4. So as I'm traveling along on the x-axis, my friend that's on the curve is traveling closer and closer to this open circle at -4 for the y value. So therefore the limit as x approaches -3 from the left, from the right of f of x is going to equal -4. For step 3, we're asked to find the limit as x approaches -3. And you notice there's no plus or minus like an exponent for this particular limit. So it's understood to be, whether I'm coming from the left or the right, what's the limit? From step 1, I found the limit as x approached -3 from the left was +4. But when I come in from the right, I get -4. So in order for the two-sided limit to equal, these two values have to be the same. So therefore, it does not exist. And I'll just write it as D, N, E, and that's acceptable for me on the test when you're doing the written work. But I think on Hawks, all you have to do is circle or select the box does not exist. But writing it out, D and E, is acceptable. It's not just acceptable, it's what students write when I taught Calc 1. For step 4, we're asked to find the limit as x approaches 4. And again, there's no plus or minus as a superscript. So therefore, we know this is a two-sided limit for f of x. And I just got to say something. I really, really like this book because instead of just jumping into the two-sided limit, the book has structured so that first they only did left and right hand limits. Then they come in and do an example where you look at the left, you look at the right. If they're not the same, then it does not exist. If they are the same, it's equal to that value. So that's what I love about this book, that it's scaffolded. So you get step by step by step so that you're not caught off guard and falling down the steps. But anyway, let's continue. So now we want the limit as x approaches 4. So I'll go ahead and find 4 on the x-axis, and here's 4 on the x-axis. And I can already see that when I'm coming in from the left-hand side, and I'll go ahead and I'll highlight this time. Let's do it in red for left. And then let's do blue for the right. So when I'm coming in on the left-hand side, I'm going to be again on that squiggly part of the graph. And I notice that the y value is going to be 3. But when I'm coming in on the left-hand side, I'm going to be on the graph that looks kind of almost like a half of a parabola that's below the x-axis and then it shoots above. But as I get closer and closer to 4, I see that I'm getting closer and closer to this ordered pair. Let me go ahead and write down the 2 ordered pairs. So one ordered pair is 4, -1 when I'm coming from the right. And when I'm coming from the left, the ordered pair is 4, 3. So we can clearly see it does not exist. Now, you don't need to necessarily write all that down on the test, but you do need to, oh, you know what? Yes, you do. I lied. Such a liar. You don't have to draw these pictures, but you do need to write this. So you need to write that the limit as x approaches 4 from the right of f of x is equal to -1. That's when we're on the blue shaded region that has the ordered pair 4, -1, so the y value is -1. And then when we take the limit as x approaches 4 from the left of f of x, now we're on the red graph and we have a y value of 3. So therefore our limit is 3. So therefore the two-sided limit as x approaches 4 of f of x does not exist, and we'll just abbreviate it D and E. Now, if it was multiple choice, you could just pick D and E, but if you're writing out your solution, you need to show your work. So I hope this video on using the graph to find the right, left, and two-sided limits has been helpful.